Okay, let's quickly talk about how to save something to save the result of a function to a variable, and then we'll talk quickly about modularity, and then we'll talk about the assignment in the next video. So saving to a variable the result from a function is actually fairly straightforward. You'll probably wonder why I am actually showing you this before. You'll probably wonder why I'm showing you this at all, really. It starts out like normal. Result of function, let's call it. We declare a type. Obviously, we have to know the type that the method returns, but that's fairly straightforward in this scenario. So we declare an int and we name it result of function. And we can set it equal to main dot some function 100, let's say. Okay, so obviously the result of this is 201. But this is literally it. Like if we do system.out.println result of function, and then we click compile, we will actually see that if we go to main, void main string, run, and then we reopen our console window, we see 201. Okay, fairly straightforward. There's really not much to this. Basically what is happening is Java is going through and seeing that, oh, there's a function here. Alright, I will jump inside of it with this value, do the work, and produce a value. Java then sort of puts that value right here as a drop-in replacement, in this case 201, and then realizing that it says int result of function equals 201, it will store that value of 201 in the result of function memory space, let's say. And then, of course, when we call system.out.println, system.out.println reaches out into that result of function memory space, grabs whatever is there, formats it the way it needs to be formatted, and then puts it on the console. Okay, fairly straightforward. Now, there is one other thing that I would like to talk about today that will take probably another couple of minutes to deal with. When you create a function in Java, your first goal should be to define what comes in to produce a particular result. So in this case, what we wanted to do was we wanted to map a function from algebra into a method, okay? In this case, 2x plus 1. And we expect a certain result. We expect that no matter what number we put into the function, we should ultimately get out an odd number. Like this will never produce it will always be an odd number because it is an integer. Okay? You can't play that any other way. So that being said, we expect to take in an integer of any value and expect to get out some integer that is an odd number. And your function, once it's defined that way, should always do that. Even if you have to change the insides of the method for some reason, it should always follow that same, if you put this in, you're going to get this out sort of deal. And this is the idea behind modularity. The idea that there are different pieces of your program that perform particular actions, and the user of your methods, of your program's methods, shouldn't really have to know how those actions are performed, as long as they know that if they put one thing in, they can sort of expect what they're going to get out. Okay? So let's look at an example of this. Obviously, return 2 times input plus 1 does what we want it to do. But let's say we had a variable called result, and we say int result is equal to input. Okay, still not right, but what if we said result equals result times 2? Still not there. Okay, result equals result plus 1. Okay, now the only thing that we have to do is set our return statement equal to result. And this will produce the same results as what we put in, as what we had before. It is the same function, just broken out a little bit more. And this is that same idea behind modularity. We changed the inner bits of one of our methods, but it won't affect anything else in the program. Everything in the program is isolated from everything else. If you change something, provided that you're still following the guidelines that you set out originally, in this case our guideline was to take in an int and produce an odd number, as long as you are still following those guidelines, there's really no reason why any other piece of the program should have to know how another piece of the program does its work. That idea of modularity, that you could go in and change something, and as long as it's still following the same set of ideals, produces the same result as what you wanted to get out of it from what you put into it from the beginning, then you're good. And modularity will become a big part of robot programming, of isolating different systems on the robot so that they are their own thing, and what your ultimate goal is to bring them together in an elegant and concise way that if you had to change something later, it's not going to blow up the rest of the program in some way, shape, or form. So now that I've said this, this video will be stopped. As I said, this one's going to be a lot shorter. The first one was about 22 minutes long. This one's going to be about 8.5 probably. The next thing we'll talk about is Chapter 6's assignment, which I think will be fairly easy. And then we will move on to talking about Chapter 7 content, or at least I will. You may decide to take breaks from week to week, and that's perfectly fine. I don't expect you to do this all in one sitting. If you are, oh goodness. But that being said, this one is done.